Okay, physics of energy. We are talking about energy here. Now, energy is what we are going to talk about today. All right. So, if you are being asked what is energy, there is just a simple explanation. Energy is the ability to do work. Remember, we talked about work. Now, energy, the ability for you to perform that work, that is it. That work has been done. Now, the energy is you being having that ability or capability to do that work, and that is energy. So we have different forms of energy. Different forms of energy. Yes, research has helped us to make sure that different forms of energy are being used, harnessed, and conserved. Okay, we are going to talk about some of these forms of energy. Most of them you know them, most of them you are likely to be new to it. Okay, let's talk about mechanical energy, the energy in machines. Alright, we know that machines are one of the things that we use to produce energy, to generate energy. Example, your generator is a machine. Alright, now the next one is electrical energy. That is electricity. Electricity. We use the electric energy to perform many things. We use it to do many things. The energy that is in electric has been harnessed to lights and to other sources. Okay, light energy, the energy in a bulb, in a light bulb. There is an energy in a light bulb, in a lighting bulb. Okay, imagine there is a darkness, or there is a dark room, and you position a bulb and that bulb has light. What happens? The illumination comes. That is what we call luminous energy. There is illumination in your bulb. That is light energy. Okay, solar energy, the energy of the sun, which we all know about. It has been one of the conservative methods that we use now to generate electricity in Nigeria. Yes, we all know that solar. So it's one of the forms of energy. All right, rest energy. You understand by rest energy? Yeah, rest energy. What is it? It means an object or a body at rest. Now, a body at rest is said to have a particular energy. Now, there's what we call, we will go there, we'll still go there. Energy of a body at rest and energy of a body in motion. Now, you exist, even an element, or let me use a substance that is being dropped. There is an energy it is exhibiting on this surface. So there is an energy of a body at rest. Okay, now we have nuclear energy. Maybe you may not have known, because I know Nigeria has not been introduced to nuclear energy. It is in the Western that they use it to generate electricity. Now they use nuclear elements like uranium to produce energy, to generate nuclear weapons, to create bomb explosive, and is an energy source. Okay, now sound energy. Sound is an energy, just like I'm speaking. Is an energy, is vibration coming out from the vocal cord. So sound energy is another energy. It's another form of energy. Audibility. Without the sound energy, you can't be audible. That's the reason why there is an energy in your sound. Chemical energy. Every chemical has an energy. That's the reason why it has the character of having an effect wherever it's being found. Okay, let me use this chemical chlorine that we use in washing clothes, detoxification of water. If it does not have that energy, can it do that? No, it will not have the potentiality to clean water or to clean your clothes or to be used as bleach. Because it has that energy, that is why it is being used. Heat energy is the energy of expansion. Heat energy is the energy of expansion. You cook your food, you warm your food, is through heat energy. If there is no heat, there is no warmness. Heat energy is another form of energy, which is a good source. Kinetic energy is energy of a body in motion, a moving vehicle, a flying aeroplane, a flying bird, a moving ball, all those things that are in motion, they are exhibiting kinetic energy. Gravitational potential energy. Now, I know why we put it gravitational potential energy, because gravity is a field. Gravity is a field. If you go to the space, there is an energy you are going to exhibit in the space. If you come here on earth, you are expected to exhibit a particular gravitational pull. If you go there, you will not exhibit it, because they are two different fields. So gravitational potential energy is the energy existing in the field of gravity. Okay, elastic potential energy. Elasticity of a substance. Elasticity is defined as the coming back to the original size of a material that has been drawn at length. I repeat, coming back to the original size of a material that has been drawn at length. Okay, so when you draw a material at length, it comes back to the now there is an energy that exists that brings it back to its original size, and that is what we call elastic potential energy. All right, let us move to mechanical energy. Mechanical energy is the energy in machines, is the energy that we use day to day in our dailies. Okay, this mechanical energy has been used in forms that have been brought down as types of energy. It has been brought down to forms that have we call types of energy. Now it's called the forms are kinetic energy and potential energy. Kinetic energy and potential energy. Kinetic energy, like I said, is the energy of a body in motion. If I'm moving, I'm exhibiting kinetic energy. If a motor is running from one point to another, that motor is exhibiting kinetic energy. If a bird is flying, that bird is showing kinetic energy. A moving mechanism is exhibiting kinetic energy. Remember, that body is in motion. Pardon me. Potential energy. This energy is the energy that is being exhibited by a body at rest or in a place. If I am standing here, there is an energy that keeps me standing, only standing. An apple on a tree, there is an energy that keeps that apple hanging on a tree. An orange that is ripe, that is on a tree, there is an energy holding it. Even coconut, there is an energy holding it. A bird perching on a tree, there is an energy holding it. How do we calculate those energies? We are going to talk about them. All right, let us talk about kinetic energy. The formula, if we want to calculate kinetic energy, the formula for kinetic energy is 1/2 mass times velocity square. Half of mass times velocity square. That is how to calculate the energy. Remember, I told you that is the energy of a body in motion. That is why we have velocity. Are we there? All right. We have potential energy. Energy of a body at rest. At this point, we have mgh. A body at rest. Now, that body at rest, we have mass, acceleration due to gravity, and height. It must have mass, acceleration due to gravity, or height. Okay, now remember that acceleration due to gravity and acceleration are the same. The only thing there is you need to know that if a body is suspended and up, let me say a body that is up, it is disobeying the law of gravity. Let me say I threw this pen up. As this pen is moving up, it is disobeying the law of gravity. But immediately it's falling down, it is obeying the law of gravity. So that is what we need to know. If the question you are being asked says that the body is moving up, you have -10. If the question says that the body is coming down, we have +10. That means G equals to -10 and G equals to +10. Note this just at the back of your mind because it is very important. Now, here at kinetic energy, we are not talking about acceleration, we are talking about the velocity, because the motion is what we will use to calculate the energy. Now, this point, it is the acceleration, whether it's accelerating or it is at a particular point. Remember, a body at rest is said to be uniform acceleration. Remember that. Don't forget, a body at rest is said to exhibit uniform acceleration. All right. Mass times acceleration due to gravity times height. If you don't have height, you may have distance. Hope you are following. Okay, now we are going to talk on calculations on these types of energy. Let us move further.